Welcome in. Our objectives for this video. We want to be able to classify our elements using the periodic table. We'll talk about metals, nonmetals, and semimetals. We'll talk about main group and transition elements, and we'll identify the names for groups 1, 2, 17, 18. As we saw in our previous video, our atoms are made up of protons, neutrons, and electrons. So we're going to talk about, in this video, what it means when we change the number of protons in our atoms. As it turns out, the number of protons in that nucleus dictate what element that atom is. If you have 6 protons in that nucleus, that means you have to have a carbon atom. Likewise, if you have a carbon atom, it must have exactly 6 protons in that nucleus. The number of protons in the nucleus, we give it the letter Z, and we call this our atomic number. The number of protons dictates our element. As we said a few times, there's about 118 elements that might possibly exist that we've found so far. And we show them on the periodic table of elements, where we can abbreviate, instead of writing out carbon every time, we can abbreviate with a 1 to 3 letter symbol. In this case, carbon is given the letter C. On the periodic table, we'll have a list of our elements. They'll be listed out with that letter. Sometimes there's the name written out underneath it. And in addition to the letter, we have that atomic number. Here is our number of protons. Here is our symbol. And here's our name. Here is a version of the periodic table. It goes all the way out to number 118. If we want to do one of these examples, if we're looking for something like sodium, sodium is number 11 on the periodic table. And so we have our atomic number 11, the chemical symbol Na, as our answers for sodium. Some of our chemical symbols are intuitive. We saw C for carbon. Some are a little bit less intuitive. Well, we can't have C for cobalt, so we use CO. Some are based on the Latin root. Na for sodium is from the Latin root natrium. So we'll get some practice looking at these elements and learning these chemical names. Do your best to know what they are, but if you forget, you can always ask me and I'll try to help you out. Now that we've seen the periodic table and seen some of the information in those little boxes, let's talk about how it was developed. What is the point? Why is it organized the way it is? Well, our modern periodic table was first built in 1869 by Dmitri Mendeleev, where he knew about 65 elements. And his plan was to arrange them in terms of increasing mass. And then instead of just a list of our elements in terms of mass, let's start a new line every time that our elements have similar properties to each other. So here, lithium and sodium are both very reactive metals. When we're typing this out, let's hit enter and start a new line here so that our sodium and lithium get to be right on top of each other, forming a family of similar elements. Mendeleev noticed that, this works out really nicely. Lithium, sodium, potassium, they all behave the same or similar, very reactive metals. And the next element over, if we're thinking about beryllium and magnesium and calcium, those next elements over also form a nice family. These are reactive metals, but less reactive metals. Likewise, our column at the end, our family at the end, everything before also forms a nice family. Helium and neon and argon are all non-reactive gases. We call this a periodic law. If we arrange our elements in this two-dimensional chart, we end up with columns that form nice families, that form periodic trends and columns that behave similar to each other. In Mendelev's original periodic table, he had some gaps, and like we said, we only knew 65 known elements, and so he predicted that there should be a couple of more elements that we can find, and in fact, within a few years, people found those elements, predicted exactly what they should behave like, what kind of chemistry and reactivities they should have, and lo and behold, they were discovered really quickly. Some terminology for our periodic table: we can call our horizontal rows our periods. These are the side-to-side periods. Our vertical columns we call groups. Our groups we can number usually 1 through 18. Our periods we can number 1 through 7. We're going to introduce a number of ways to categorize our elements. We can start with main group compared to transition elements. On our periodic table, the main group elements are the tall columns on the left, 2 tall columns on the left, and the tall columns on the right, those 6 tall columns on the right. The transition elements are separating those main group elements. The transition elements are going to be these 10 short columns in the middle. A second way to categorize our elements is based on their properties. Some of our elements are metals. Some of our elements are nonmetals. Metals behave like we expect them to. They are hard, shiny, conduct electricity, conduct heat. In terms of chemistry, they will lose their electrons during our reactions. And our metals get to exist on the bottom left of our periodic table. Nonmetals are kind of the opposite. They appear on the top right of our periodic table, and they're generally poor conductors. In chemistry, they like to gain electrons during reactions. And in fact, our nonmetals are used to build up organic molecules and build up most compounds that we see in biology. We can see that there is a third category. There's kind of this in-between state where you have a semi-metal or a metalloid. These are metals that are kind of halfway in between. Maybe they have properties of metals and nonmetals, or maybe their properties are in between those of metals and nonmetals. Our semi-metals actually are very useful. Things like silicon are not conductors and not insulators. They are semiconductors, which allows us to manufacture transistors and devices and circuits. We can visualize this on the periodic table. Note here, this periodic table has a bold zigzag line on that right-hand side. That bold line is the divider between our nonmetals and our metals. Everything to the bottom left of that line gets to be a metal. Everything to the top right gets to be a nonmetal. And in this case, hydrogen exists as a nonmetal. Our semimetals, the ones that are somewhat in between metals and nonmetals, are the elements that are generally touching that bold line. So something like boron, silicon, germanium, arsenic, antimony, tellurium, etc. Those elements touching the bold line get to exist as these metalloids. Lastly, we said our vertical columns, our vertical groups, are grouped based on their properties. Some of these columns have special family names. The first column that I'll talk about is group 1, the first column on the very, very left. These are known as the alkali metals. They are those very reactive metals. In fact, they're so reactive, they react with water in the air. You need to keep them stored in oil so that they don't just spontaneously react. Our second column, column 2, is the alkaline metals or the alkali earth metals. These are our semi-reactive metals. They react vigorously, but maybe not with the water in the air. Something like magnesium will burn very brightly, but it's stable in terms of the atmosphere. Third, we can talk about group 17. These are the halogens, 17 or group 7A. The halogens are nonmetals, but they are very reactive nonmetals. We have things like fluorine, chlorine, bromine, iodine. These are our reactive nonmetals known as the halogens. And then finally, looping around here to our noble gases. These are the elements in group 8A, or I like to call it group 18. The noble gases are non-reactive gases. They're called noble gases because they are inert. They are non-reactive. They stay away from the common elements like these snooty nobles. All right, here are those families in the periodic table. We have our alkali metals as group 1, alkaline earth metals as group 2, the halogens as group 17, and our noble gases as group 18. For practice, we have a couple of statements. Are these true or false? Which ones are never true? If they are true, can we give an example? Can elements be both transition elements and metals? Here is our periodic table again. Our transition elements are the ones in the middle. Our metals are the ones to the left of that bold line. Oh, in fact, all of our transition elements are metals. We can also call those the transition metals. If you want to choose one for an example, I like silver, that's fine, but there's many examples here. Question 2, can an element be a transition element and a semi-metal? Again, our transition elements are those in the middle of the periodic table, and our semi-metals are those that are touching this bold line. It does not seem like there's any overlap at all here. This has to be false. There's no example. We have 2 more examples here. See if you can do those for practice. Write down your answers. All right, and one last bonus thing for fun here. We're going to use the periodic table that we've seen previously, but these aren't the only periodic tables that exist or that people might use for certain applications. Here's a bunch of examples of our same 118 elements, but arranged in different kind of fun ways. And there we go, we've made it to the end. At this point, we can classify our elements on the periodic table as metals, nonmetals, or semi-metals, main group elements or transition elements, and as the names of group 1, 2, 17, 18. Those are the alkali metals, alkali earth metals, halogens, and noble gases. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.